Hello everyone, this is Mr. Kaviani, and by the end of this video, you should be comfortable performing calculations with numbers in scientific notation. As you've probably seen scientific notation before, this is just a brief refresher. Scientific notation is a way of expressing numbers that are either too large or too small to be conveniently written in decimal form. One example of this, if you're taken in chemistry class, you're familiar with Avogadro's number, 6.02 times 10 to the 23rd, right? The number of atoms or molecules in a mole. What we say is this number right here is the significand, that's the official term, and then this is our exponent. And so essentially we can represent a very long number, one with 23 decimal places past this number, using scientific notation. The significand is always between 1 and 10 in normalized scientific notation form. And this can make it really easy to add, multiply, and divide numbers that are very large and be otherwise difficult to do by hand. This graphic on the right shows an example of going from standard notation to scientific notation, right? You move the decimal place over a certain number of places until you have a number between 1 and 10, and then you count the number of decimal places. So in this case, if I move the decimal place over 1, 2, 3 to the left to turn 4,500 into 4.5, I represent that with a positive integer, meaning that this 4.5 will actually have another 1, 2, 3 decimal places. Same thing for 0.0677. If you move the decimal place over 2 to the right to get 6.77, I would show that as a negative 2 to indicate that that number is actually 2 decimal places smaller than the way I've written it. Let's practice adding two numbers in scientific notation. To add two numbers in scientific notation, you'll first need to make sure that they have the same power of 10 exponent. And so in this case, 3.84 times 10 to the 8th and 6.38 times 10 to the 6th have different powers of 10. This one's to the power of 8 and this one's to the power of 6. So I can either turn 3.84 into a power of 6, 10 to the 6th, by moving the decimal place over 2 to the right. So if I make it 10 times 10 bigger, this will go from 8 to 6. Or I could move the decimal place here 2 to the left and then make this 2 bigger. That would be 8. So if I make the number smaller, I make the exponent bigger. That's how I remember it. I'll go ahead and just use 384 times 10 to the 6th plus 6.38 times 10 to the 6th. And that will give me a value of, right now I'll just go ahead and add the significance. So the way this works, the exponents don't change, right? So the 6 and the 6th, that means I can add them together. Just like if you were to add, for example, x squared plus x squared, you would get, right, what? 2x squared. The square doesn't change. So 384 equals 384 plus 6.38. And that whole thing would be times 10 to the power of 6. And that would give me 390.38 times 10 to the power of 6. But that's not in scientific notation in normalized form, right? I need to convert that to a number between 1 and 10. So I'll move the decimal place over 2 places to the left, meaning I'll increase this from a 6 to an 8. And so that'll give me 3.9038 times 10 to the power of 8. There we have it. All right, if we were to add 6.38 times 10 to the 6th and 4,200 together, I'll need to convert one of those, right? For the 4,200, I'll go ahead and put that in scientific notation. That would be, let's see, 1, 2, 3, so 4.2 times 10 to the power of 3. And just double check yourself. If it's positive, that means the number should be big, and in this case it is, so I know I did it correctly. Then I would also, I could take this all the way to the 6th if I wanted to, but I'll go ahead and take 6.38 times 10 to the 6th and put that in terms of times 10 to the 3. So that would be, let's see, 1, 2, 3. So 6,380 times 10, and that would be, so I moved my decimal place over 3 to the right, 3 times bigger, so that would now be 3 times smaller, times 10 to the 3rd, plus 4.2 times 10 to the 3rd. So I can see right there, that'll give me 6,384.2 times 10 to the 3rd. And to convert this to scientific notation, I would go 1, 2, 3 decimal places back. So that would be 6.3842 times, let's say I just made the number 3 decimal places smaller. So I'm going to make the exponent bigger. There we go. Awesome. There's our final answer. When it comes to multiplying or dividing numbers in scientific notation, we're going to use the same logic we apply when multiplying or dividing algebraic expressions. So for example, if you were trying to multiply, I'll show this up here, a 2x squared, and you were to multiply that by 3x to the power of 4, what you would do is you would multiply the coefficients together, and then you would add the exponents together, right? So you would get 6x to the power of 6. Let's go ahead and apply that to part A. So let's multiply 5.98 times 10 to the power of 24 and 1.991 times 10 to the power of 30 together. That would be the coefficients multiplied together, all to the power of 10, 24 plus 30. So that would give me, in my calculator, I can multiply these two numbers together and add the 24 and the 30. It'd be 11.9 times 10 to the power of 54. And again, that's not in normalized notation, so I'll just move this one over. So make the number 10 times smaller. So I'll make this one bigger here. So that would be equal to 1.19 times 10 to the power of 55. And I'll go ahead and box that. All right, now let's square 1.496 times 10 to the power of 11. So if I were to square that, right, that's the same thing as saying all of this to the power of 2, right? Or the same thing, this multiplied by itself. Now, I can square numbers in scientific notation the same way I square variables with exponents. I can square 1.496 and multiply that by 10. And when you have an exponent raised to an exponent, right, that would be 11 multiplied by 2, right? So for just as a jog of memory here, x cubed squared is x to the power of 6, right? That's that 2. We would multiply the 2 and the 3 together. So this would give me 1.496 squared on my calculator is 2.238 times 10 to the power of 22. All right. It's also important when you're doing problems in scientific notation to keep as many digits as possible. I would say at least 3 decimal places, because these are very large numbers, and even 1 decimal place different represents a huge change in the overall value of that number. Now, to complete this, we'll go ahead and divide our answer from part A by our answer in part B. So that would be 1.19 times 10 to the power of 55 divided by 2.238 times 10 to the power of 22. And division works the same way as, again, with variables. In this case, we will subtract the exponents and we'll divide the coefficients. So that would be 1.19 over 2.238 times 10 to the power of 55 minus 22. Okay, and that would be equal to 0.532 times 10 to the power of 55 minus 22 is 33. And again, that's not in normalized notation, so I'll move this one over to get it between 1 and 10, make the number 10 times bigger, make the exponent 1 smaller. So that would be 5.32 times 10 to the power of 32. All right, this completes our refresher video on scientific notation. These skills should come in very handy when solving problems involving universal gravitation, as the numbers we deal with are often very large.